You have probably watched a semi-truck pull away from a stoplight and never thought twice about it. The pedal goes down, gears change, the truck rolls. Simple. But here's what nobody tells you. Inside that clutch, right now, there are weights spinning at thousands of revolutions per minute, flying outward, doing maintenance work no mechanic has to think about anymore. Those spinning parts are centrifugal weights. Why does every heavy truck clutch in America have these spinning weights hidden inside it? Is it gimmickry or a backup system? What happens if they ever fail? And why did trucking need this invention so badly that the entire industry restructured its maintenance schedules around it? The easy answer is self-adjustment, but that barely scratches what this mechanism is actually doing, and why it took engineers almost a century to put it inside a truck clutch housing. The answer connects to something you loaded into your grocery cart this week without thinking about it. And here's the part that should bother you slightly. Every semi-truck on every interstate depends on centrifugal force doing unpaid maintenance labor nobody in the cab can see. The system that stocks your store, delivers your packages, and fuels your car is riding on physics from the 19th century, quietly readjusting itself every time the engine turns. By the end of this, you will understand why, and you will never look at a truck the same way again. But let us start with what everyone gets wrong about truck clutches. The usual reaction is reasonable enough. A clutch is a clutch. You press the pedal, a disc separates from a flywheel, the engine disconnects from the transmission, you shift gears, you let the pedal out, the disc reconnects. A car does it, a truck does it, same mechanism. But that's where the picture falls apart. A truck clutch isn't a scaled-up car clutch. It's a fundamentally different machine doing a fundamentally different job. And the torque numbers alone should make that clear. A modern heavy-duty diesel produces 1,500 to 2,000 pound-feet of torque. That's the kind of force that would twist a typical car transmission into a metal pretzel in seconds. A truck clutch has to absorb all of that, repeatedly, across hundreds of thousands of shifts, while the driver presses the pedal with a leg that gets tired somewhere around Tulsa. But the math gets worse. To clamp that much torque without slipping, the clutch has to exert enormous pressure on its friction surfaces. Too much pressure on the pedal side, and drivers physically cannot operate it over a 10-hour shift. Too little pressure on the friction side, and the clutch slips, overheats, and burns out in miles, not years. Heavy truck clutches solve this with clever mechanical leverage, multiple friction surfaces, and carefully designed spring systems. But all of that creates a problem nobody in the car world has to deal with. Those friction facings wear. Every time the clutch engages, a microscopic layer of material comes off. Over tens of thousands of miles, that adds up to millimeters of wear, and millimeters matter. As the facings get thinner, the release mechanism drifts out of adjustment. The pedal feel changes. The engagement point moves. And if you don't catch it in time, you end up with clutch brake damage, hard shifting, premature failure, and often a truck sitting on the shoulder of an interstate somewhere in the middle of the night, waiting for a service call. For decades, the solution was brute force. Fleet mechanics scheduled clutch adjustments every 30,000 miles or so. Thousands of man-hours, millions of dollars across the industry, constant downtime for working trucks. Miss an adjustment, and you would get the failure anyway. This was considered normal. This was considered the cost of doing business in heavy transport. And for most of the 20th century, nobody had a better answer. But that's only half the story. Because the fix, when it finally arrived, turned out to be hiding inside the clutch itself. The question is simple and absurd at once. How does a clutch fix itself while the truck is rolling? It sounds like the kind of thing that should not work. But the answer is so mechanically clean, it almost feels obvious in hindsight. Centrifugal weights, small metal masses mounted on pivots inside the clutch assembly, spinning with the engine. And as the clutch rotates, Those weights want to fly outward. That outward motion is predictable. It is proportional to engine RPM, and most importantly, it can do work. Engineers at Eaton and elsewhere realized something the rest of the industry had missed. If you tie those flying weights to a tapered ring or a cam mechanism, every revolution of the clutch becomes a tiny micro adjustment. As the friction facings wear thinner over time, the weights move progressively further outward, camming the adjustment ring by fractions of a millimeter at a time. The release bearing stays where it needs to be. The pedal feel stays consistent. The engagement point does not drift. The clutch is, quite literally, fixing itself while it spins. And this connects to something that showed up on your doorstep this week. But we will get to that. Think about what this actually means in practice. It's clutch maintenance happening at 1,800 revolutions per minute in the dark on a highway in Wyoming at 2 in the morning. The driver has no idea. The dispatcher has no idea. A maintenance operation that used to require a mechanic, a service bay, a floor jack, and an hour of labor is now happening continuously and silently as a byproduct of the clutch just doing its job. But the math gets wilder when you zoom out. A fleet of 500 trucks before self-adjusting clutches meant a scheduled stream of units pulled off routes for clutch adjustment. This added thousands of labor hours per year, with dispatchers juggling service bays and delivery windows. And still, despite all that discipline, breakdowns happened. A clutch that was due for adjustment could strand a driver at a weigh station overnight while they waited for a roadside mechanic. The centrifugal self-adjuster effectively eliminated most of that. Fleets reported longer clutch life, fewer breakdowns, lower labor costs, and predictable maintenance schedules. Entire line items disappeared from maintenance budgets. And that is before you even get to what this meant for small owner-operators who could not afford a breakdown in the first place. But here is where it gets genuinely strange. This idea did not start in trucking. The centrifugal clutch principle is older than the automobile. It predates the interstate. It predates the diesel engine. It shows up in 19th century industrial machinery, where engineers used spinning weights to engage and disengage loads long before anyone was trying to build a truck. The physics is almost embarrassingly simple. Rotational speed creates outward force. That outward force can be harnessed to do mechanical work. You can use it to engage a clutch at a certain RPM, disengage one, trip a governor, or regulate a valve. Victorian-era factory floors use the principle everywhere. But here's where the story gets weird. The centrifugal clutch, for most of the 20th century, got pigeonholed. It became the small engine solution. Chainsaws used it, because you need a chain that does not spin at idle and engages when you pull the trigger. Go-karts used it, because a kid cannot slip a clutch smoothly at 8 years old. Mopeds, lawn equipment, string trimmers, small industrial gear. That is where the centrifugal clutch lived. It became synonymous with low horsepower, low torque, low stakes applications. And for decades, the engineering culture in heavy trucking looked at that and thought, not for us. Bigger means, tougher means manual. The idea that the same physics chainsaws used could do serious work inside a Class 8 truck clutch was not obvious. It required a conceptual leap. Not centrifugal force to engage the clutch, but centrifugal force to adjust it. That distinction is what took a century to land. Every decade that passed without self-adjusting truck clutches was another decade of fleets budgeting thousands of labor hours for clutch linkage work, another decade of drivers stranded on shoulders because a clutch drifted out of specification between service intervals, another decade of small owner-operators going bankrupt over a maintenance failure they could not afford to fix. The conceptual breakthrough finally came together in the late 1980s and early 1990s. Engineers reapplied the 19th century principle inside the clutch housing itself, wrapped it in a wear compensation mechanism, and started shipping self-adjusting clutches to heavy truck original equipment manufacturers. The same physics that had been running chainsaws since before World War II was now doing silent maintenance work on every long-haul truck on the continent. And here is the part people forget. The invention did not just make clutches last longer, it restructured how fleets plan their operations. And that is exactly why what you are about to hear should change how you see every semi-truck you pass on the interstate. The scale is the part that takes a minute to process. There are roughly 2 million Class 8 trucks operating across the United States on any given day. The vast majority of them are running self-adjusting clutches. Every one of those clutches is doing micro adjustments thousands of times per hour across millions of miles, across every highway and interstate in every state. Nobody is watching this happen. Nobody has to. You have been riding on this invisible maintenance work for your entire adult life. The groceries in your fridge moved through it. The Amazon package on your porch rode on it. The gasoline in your tank was delivered by a tanker truck whose clutch has been quietly adjusting itself since it rolled off the lot. The lumber at Home Depot, the steel in your car's frame, the beer at the bar down the street, the flour in your local bakery, the medical supplies at your hospital. All of it moved through clutches that were fixing themselves as they spun, in the dark, across empty stretches of highway, while the drivers slept at rest stops or ate at truck diners. The American Trucking Association estimates U.S. trucks move roughly 72% of all domestic freight by weight, which means nearly 3 out of every 4 pounds of everything you have ever bought passed through a clutch system that centrifugal force was maintaining in real time. You have never seen it. You have never heard it. You do not know the name of the company that makes most of them, but you have been depending on it every single day. And here's the part that should hit slightly harder. The drivers benefit from it without thinking about it. The dispatchers benefit from it without thinking about it. The fleet owners see the difference in maintenance budgets, but almost never stop to trace the line back to a century-old industrial principle reapplied in a housing the size of a dinner plate. This is the quietest piece of critical infrastructure you have ever interacted with. The hum of the interstate freight system is being maintained, in part, by physics that is older than every person who works inside it. So here's where you actually land. You started this video looking at a truck clutch and thinking, pedal, disc, done. But what you were actually looking at was a 19th century physics principle rediscovered in the 1990s. Hidden inside a housing you will never see, doing maintenance work no mechanic has to schedule on a fleet of roughly 2 million trucks moving nearly 3/4 of all American freight. Every grocery trip, every delivery, every hot meal at a chain restaurant, every gas station fill-up connects back to those weights quietly camming against an adjustment ring at highway speed. The pedal feel you never noticed is consistent because centrifugal force is working in the background. The breakdowns that did not happen are invisible for exactly that reason. You are not just looking at a truck clutch. You are looking at one of the most elegant pieces of silent self-maintenance in the entire transportation industry, built on physics older than the automobile itself. And if you think the clutch is doing quiet work no one sees, wait until we get into what is happening inside the transmission it is connected to, where a system even stranger keeps 18 gears synchronized without spark plugs, without computers, and without anyone noticing.